Hello, and welcome to our video on an introduction to polynomials. Polynomial is an expression which includes x terms with zero or positive whole number powers. Examples of polynomials we've already looked at. We have y equals 2x plus 6, which is a linear equation, because the highest power of x is 1. We have this example here, which is a quadratic equation. Highest power of x is 2. And we're moving on to some new ones here. This one is a cubic. Pen's not working today, because the highest power of x is 3. And the last example I've got here has the power of x of 4, highest power of x, and this one's called a quartic. Now when you've got polynomials like this, sometimes they have every term with different x powers is in the equation, like these two. Sometimes you're missing one, so you might notice this one is missing an x squared term, and this one has a 4, a 3, a 2, and it's missing an x term. That's okay, it's still a polynomial as long as it only has powers with 0 or positive whole numbers. So a constant by itself, just y equals 4, could also be a polynomial, because it would be x to the power 0. The following here are not polynomials. Negative powers. For example, y equals 1 over x, which is the same as x to the negative 1. This one has a negative power, so it's not a polynomial. Non-whole number powers, for example, y equals the square root of x is the same as x to the power half. The power is not a whole number, not a polynomial. Combinations, for example, y equals x squared plus root x plus x plus 2. And you might say, okay, this part's a polynomial, this part's a polynomial, this part's a polynomial, but this part has a non-whole number power. So if we have at least one term that doesn't fit the polynomial mold, then this is not a polynomial either. Some terms that we need to remember when we're talking about polynomials. The first one is coefficient, and you remember this from previous work. It's the number in front of a pronumeral. So let's put up an example here. I'll put it in green. Two x to the 4 minus 3x cubed minus 2x squared minus 2. Okay, I'm going to use these examples for all of these terms. Coefficient, number in front of a pronumeral. The coefficient of x cubed is -3. You need to keep the sign with the number that it goes directly after. The coefficient of x to the 4 is 2. Constant term is a number without a pronumeral. In this example, it's -2. Remember, keep the negative with the number. The leading term is the first term, and we usually write the each term in order of descending powers. So it would usually be the highest power of x. In this example, leading term, you write the whole term, not just the coefficient. 2x to the power 4. Notation. Instead of writing y equals at the start of our equation, we can also use px, and we say that as p of x. When you're reading it, you say p of x, and it means, can't write apostrophes today, p of x, it means a polynomial with variable x. So the letter in here is the variable you have in your polynomial. So p of x could be, it would have to have x's in it. X squared plus 2, for example, could be a polynomial in x. If you're not using x as your variable, you would put the letter that you are using in the brackets. So you could have p of a equals a cubed minus 3a. That would work as well. You can use any letter in there. We can also use q of x. If you've already defined p of x in one question, and in the same question you want to define another polynomial, you can use q of x or q of a or q of whatever you need. When we put a number in the brackets, so no more x, we put p of 2, it means to substitute x equals 2 into the equation. For example, if p of x equals 3x minus 2, find p of 2. So all we need to do is write p of 2 equals, and substitute x equals 2 in, minus 2 equals 6 minus 2 equals 4. Thanks for watching the video today.